So now we started building some classes, and we said a key advantage is that we get to cluster behaviors together around instances of a class, common behaviors. Cats are a little bit different than rabbits, for example. But an even more important property of classes is that I can have hierarchies of classes, that I can have cats and rabbits, and I do, but they are also instances of animals, as are other kinds of things. So I've got, as we already started, the general idea of a class of animal, and now I'd like to create a subclass of animal that has cat behaviors. I'd like to create another subclass of animal that has rabbit behaviors. I'd like to create a third class of animal that has people behaviors. And even within people, there may be other kinds of behaviors. Students often tend to behave differently than other kinds of people. And what I'm doing is building a hierarchy. Each one of these should be a separate class. It should have common behaviors associated with cats, or associated with rabbits, or associated with people. But some of them may be shared across all of those classes. And in this diagram, all of those lie within the class of an animal. So they should have underlying behaviors. Similarly, students have behaviors, some of which are common to people, some of which are unique to students. And I'd like to build classes that reflect exactly that hierarchy, sharing the properties and the methods that are common, but having distinct properties, attributes, methods when appropriate. So this leads to this idea of a hierarchy. We've already begun to see it. And in a hierarchy, we're going to have a parent class. Here it's going to be animal, although one could actually argue that above this was the idea of an object or underlying class. But here, animal is a parent class, and it has some children subclasses. And those children subclasses all inherit the behaviors and data of the parents, unless I explicitly override them. One of the nice things then is I could add more data to the subclasses, I could add more behaviors to the subclasses, and I could decide to have one of the subclasses have a different behavior than the parent, and I can override that. And that's what we're going to do now, is we're going to build a little hierarchy and look at how we actually get those kinds of behaviors out. There's my animal class. It's just what I had before. I've got a way of creating them with an age and a name. I've got getters, I've got setters, I've got a way of printing them out. Let's see what happens if I want to build things on top of them. So everything here is, of course, an object. That means it inherits all of the pieces inside of Python. And then the new object is going to define properties that it's going to inherit from that class, but have its own properties on top of it. Let's define a cat. I want the cat to speak. It's not very impressive how it speaks, but it does have a speak method. And I also want to override the print method, because while a cat's an animal, I'd like to know when I see a cat that it is a cat. So I'm going to define a new string method associated with the class cat that prints out almost the same kind of thing. It's going to print out the name and the age. But now I'm going to ask it to print out the symbol cat to tell me that I'm looking at a cat. So I've added some new functionality with speak. An instance of type cat can now be called with those methods, but an instance of type animal will throw an error if I try and use it with a method that only belongs to a cat. Let's look at an example of that, but let's quickly remind you again. I inherit all of the properties of an animal. I've added the new functionality there, but I'm going to override other behaviors where necessary, and I don't want to have those behaviors show up in places that they shouldn't. So animals are not going to be able to speak, at least in the version I've got here. Let's build a version of that. And so I'm going to go to my computer and type this in. And let's define Jelly to be a 1-year-old cat. All right? I can set its name. Now I could actually ask what the name of Jelly is. So I could say to Jelly, give me your name. I'll use getName to get that out. And it says I don't have one. You didn't give me one yet. Okay, let's change it. And we'll say we're going to call Jelly, just for fun reasons, Jelly Belly. And now if I ask for Jelly's name, good, there it is. Now, if as a consequence, if I print Jelly, it tells me, first of all, it's a cat. That comes from the string method associated with an instance of a cat. It gives me the name of this particular instance and its age. Right? So that string method is shadowing the animal string method. And that's an important point. Remember, this is a version of an animal, but it doesn't use the animal string method when I use this. And in fact, if I wanted to go back and look at that, I could do what I just showed you there. I could print out, and here I'm going to say, take the animal class, get the string method associated with animal, and apply it to jelly. And I have to do that because jelly will only see the method associated with cat. And if I do that, it now prints out animal, jelly belly, and 1. So I can still get to that underlying method if I really wanted to use it. In a little bit, we're going to see how we want to actually take advantage of that idea. Let's make another animal, blob. This is an animal, a 1-year-old animal. And if I print it out, it tells me it's an animal. It says you got none associated with the name because I don't have one there, and its age is 1. I could change that name as well. I could say to blob, set your name. And since there's a default empty string for this, I'm simply going to give it no argument. And as we would expect from what I've shown on the slide, when I print it out, now it prints out animal, nothing, and the name. Great. I've got ways of dealing with different kinds of objects. And you can see how the methods can shadow other methods higher up in the hierarchy. I'm always going to start with the class associated with the instance and look for a method there. If there isn't one, then I'm going to go up the hierarchy to see if there's a method defined earlier on in that chain. Okay, now let's define rabbits. Again, as we had with cats, they can speak. Rabbits can also speak. In my experience, rabbits don't say a lot. So I'm going to have it say something very quiet. And similarly, I'm going to define a string method here. It looks a lot like the string method for cat, but having me tell it it's a rabbit rather than telling me it's a cat. Easy to make the change. And now, if I go back to my computer, I've already got jelly. I've defined that. I've got blob. Let's call Peter, or give Peter to be an instance of a rabbit that's 5 years old. I can now ask jelly to speak. And it uses the method from cat and says meow. Not impressive, I know, but it did the right thing. There it is. I could also ask Peter to speak. And he simply says meep. Why am I showing you this? There are 2 speak methods, one associated with rabbits, one associated with cats. And what the system does is say, given jelly, let me get what that is bound to. In the global or the top level environment, that is a pointer to an instance of a cat. And so because it's an instance, the dot says, look up inside that instance the speak method. Now I didn't define speak inside the instance, but because this is an instance, I know it's a kind of cat. I look up the speak method inside of cat, which is why it does the right thing. Whereas down here, this speak method comes from rabbit, because that's what Peter is an instance of. And that's why it prints out the right thing. I use the appropriate method by letting the instance tell me what kind of method I should look up. All right, let's have blob say something. I don't know what blobs say, so let's have blob speak. Oh goodness, it complained. And it complained correctly, because there is no speak method associated with animal. Blob is an instance of animal. When I use this, I ask, the dot says, get blob, it's an instance of animal. Look up an animal, the definition for a method for speak. There isn't one. And this reinforces that idea that while I can inherit methods from higher in the hierarchy, something higher in the hierarchy cannot access a method of a subclass. Even though both cats and rabbits have speak methods, animals cannot get to them because they are below them within the hierarchy. So I get an attribute error, exactly what I'd like to have happen. I'm going to just recapture what we've already said, but do it in a little more concise form. Which method should we use? We know that a subclass can have methods with the same name as a superclass, but we always start with that subclass. It shadows that higher level method. Subclasses can also have methods with the same name as other subclasses. I have speak in cat and in rabbit. I always let the type of the instance direct me to finding the right method to use that. And that's, as a consequence, for an instance of a class, I look up the method in the current class definition. If I don't find it, I go up the hierarchy looking for it until I either find one and use it, or if I don't find one, throw an error, an exception saying I don't know how to actually use that. That nicely encapsulates or packages names inside of class definitions associated with instances. A little bit of a messy slide, but let's introduce one more kind of animal, a person. And that's a reasonable animal to have. And I've got a number of pieces here I want to highlight out. First of all, notice this again is an instance or a subclass of an animal, as were rabbits, as were cats. I've got an init method, but it's a little bit different. So let's look at it carefully. This init method again has, as always, the self as the first argument, and it has two parameters I'm passing in, a name and an age. But I'm going to now use the underlying animal method to create the instance. And to get at it, I do what I just did. I'm going to say take animal, the name of a class, get the init method associated with that, and call it to create the actual instance. So I'm calling the animal constructor here. I'm also going to use the underlying set name method of animal to change the name associated with this instance of a person. In both cases, I have to get at it by giving the name of the class and then the name of the method that I want to use. And then finally, I'm going to simply define friends in this instance directly. So I can add a new data attribute. What I'm doing here is explicitly inheriting the init method of the superclass to create the instance. So a different formula than we've seen before. Great. Now that I got that, I can create a few other things. I've got something that creates a way of getting out the friends. I got a way of adding a new friend in. This is simply adding a name into a list of things. I can have a speak method for a person that's different than a speak method for a cat or a rabbit. I can also do some other things, and here's an instance where I'm going to get the age difference between two people. And I'm going to do it by using the getters for both instances to get the difference. And then I can actually compare those to decide I want to print something different out in terms of which one's younger or which one's older as I do that. And then finally down here, I've got a string method for a person as well, something that I want to have that's going to override the underlying string method. And as before, if I really want to use the animal string method, I could. Biggest difference here is where we started, that I can explicitly call initialization or instance creation methods of other classes within the hierarchy, and I want to do that with a person. So let's create a couple of people. Eric is a person with the name Eric, and he claims to be 45 years old. And John is also a person, and he claims to be 55 years old. I can ask Eric to speak, and he just says hello. Key point again is the instance type tells me which speak method to use. What else could I do? I could ask, what's the difference between Eric and John in age? And so if I ask for the age difference between Eric and John, it computes it and prints out the string I asked it to. That's great. I could also, though, do it as we did before, just to remind you, directly by saying, get the person method for age difference. And in this case, let's do it between John and Eric. And I'm doing it in the different direction than I did before, and it gives me out the appropriate kind of information. Just showing, again, I can do that all within this hierarchy as I've done before. Okay, what else might we do here? Let's create a special kind of person, a student. A student is a person. It's going to inherit a lot of those behaviors, and it does it, again, by using person. But remember now, person is also a subclass of animal. So a student both inherits from person, but it will also inherit from animal. And that's going to be important in certain places. I'm going to create a constructor for this, and it is going to, in this case, use the person creation method, the initialization method. And remember that used inherently a direct call to animal. So I can chain up here. But the one other thing I want to do here is a student has a major. They're computer scientists, they're economists. So I'm going to define a new data attribute right here in terms of doing that. In my experience, students often change majors, so I can do that by simply having them decide they want to have a new major. And I'm going to define a speak method for a student. And here I'm going to do something a little different. I'm going to inherit from a module the ability to just randomly pick a number. And in this case, I'm going to let you look it up. I import from the random module ways of doing random, and this particular call is going to give me back a number between 0 and 1. And that's going to allow me to define a different kind of behavior for speak here, which is that students change their mind about what they want to say, depending on how many times they've done something. And finally, at the bottom, I'm going to define a string method And that overrides the person string method, which already overrode the animals string method. All right, let's see what happens if we create people. I've got Eric, I've got Fred, and I'm simply now going to show you what happens here. If I print out Fred, because if I go back here for a second, there's the string method. It was the label student, the name, the age, and the major. Printing out Fred prints out something different because it uses the method from student. If I ask Fred to talk, well, I can do it multiple times. And in fact, the behavior changes here because each time I call it, it computes a random number between 0 and 1, and based on that value, it either says I have homework, I'm watching TV, or I'm really starving and I should go eat. Again, Fred tells me which speak method to do, and that's really nice because I don't get confused about which behavior I want to have.